P-waves are a type of body wave, called seismic waves in seismology, that travel through a continuum, and the first waves from an earthquake to arrive at a seismograph. The continuum is made up of gases, liquids, or solids, including the Earth. P-waves can be produced by earthquakes and recorded by seismographs. The name P-wave can stand for either pressure wave, as it is formed from alternating compressions, and rarefactions, a primary wave, as it has the highest velocity and is therefore the first wave to be recorded. In isotropic and homogeneous solids, the mode of propagation of a P-wave is always longitudinal. Thus, the particles in the solid vibrate along the axis of propagation of the wave energy. Seismic waves in the Earth. Primary and secondary waves are body waves that travel within the Earth. The motion and behavior of both P-type and S-type in the Earth are monitored to probe the interior structure of the Earth. Discontinuities in velocity as a function of depth are indicative of changes in phase or composition. Differences in arrival times of waves originating in a seismic event like an earthquake as a result of waves taking different paths allow mapping of the Earth's inner structure. P-wave shadow zone. Almost all the information available on the structure of the Earth's deep interior is derived from observations of the travel times, reflections, refractions and phase transitions of seismic body waves, or normal modes. P-waves travel through the fluid layers of the Earth's interior, and yet they are refracted slightly when they pass through the transition between the semi-solid mantle and the liquid outer core. As a result, there is a P-wave shadow zone between 103 degrees and 142 degrees from the earthquake's focus, where the initial P-waves are not registered on seismometers. In contrast, S-waves do not travel through liquids, rather, they are attenuated. As an earthquake warning, earthquake advance warning is possible by detecting the non-destructive primary waves that travel more quickly through the Earth's crust than do the destructive secondary and Rayleigh waves. In the same way that lightning flashes reach our eyes before we hear the thunder during a storm, the amount of advance warning depends on the delay between the arrival of the P-wave and other destructive waves, generally on the order of seconds up to about 60 to 90 seconds for deep, distant, large quakes such as Tokyo would have received before 2011 Tohoku earthquake. The effectiveness of advance warning depends on accurate detection of the P-waves and rejection of ground vibrations caused by local activity, as otherwise false positive warnings will result. Earthquake early warning systems can be automated to allow for immediate safety actions such as issuing alerts, stopping elevators at the nearest floors, or switching gas utilities off.